Scientists have just uncovered why women are nearly twice as likely to experience depression as men. And the answer lies deep within their DNA. For decades, doctors and psychologists have blamed hormones, lifestyle, and social pressure. We've heard it all. It's just PMs, it's just stress, or women are more emotional. But in 2025, researchers finally revealed something far more profound, a hidden genetic mechanism that may explain the difference in how women's brains respond to stress and sadness. Teams from Cambridge University and Kyoto University discovered that on the X chromosome, the one women have 2 copies of, lies a unique cluster of genes linked directly to emotional regulation. Among these, one stands out, NERXN3, now called the resilience gene. This tiny stretch of genetic code helps manage how the brain handles emotional pain and stress. When it's underexpressed, meaning it's not as active as it should be, women's brains become more sensitive to stress hormones like cortisol. Men who have one X and one Y chromosome don't carry the same vulnerability, simply because that specific gene cluster doesn't exist on the Y chromosome. But this isn't just about DNA or lab experiments. It plays out every day in real life. Imagine juggling deadlines, relationships, family expectations, and the constant noise of social media, all while your brain's chemistry is genetically tuned to feel stress more deeply. For millions of women, that's the invisible weight they carry. And now, science can actually measure it. Estrogen, often called the female hormone, adds another fascinating layer. It acts like a dimmer switch for mood-related genes, turning emotional sensitivity up or down. During menstruation, pregnancy, or menopause, estrogen levels can swing dramatically, and with them, the activity of genes like NRXN3 fluctuates too. The result? Mood changes, fatigue, and vulnerability to depression that aren't imagined. They're biochemical. It's not in your head. It's in your body's natural rhythm, researchers. Comparing brain scans of depressed men and women noticed something even more striking. Women's brains showed hyperactivation in regions like the amygdala and hippocampus, the centers for emotion and memory. This overactivity isn't weakness. It's the brain working overtime to process emotional information, which may have once been useful for survival, for empathy, bonding, or protecting children, but in today's world of constant digital and social stress, it can become overwhelming. Here's where the 2025 breakthrough changes everything. Using advanced CRISPR-based RNA editing, scientists were able to toggle those very gene clusters in lab-grown neural cells, switching stress response genes on or off. When they restored proper balance, the cells showed a normalized reaction to stress signals. In early animal models, this meant fewer depressive behaviors. Translation: the next generation of antidepressants might not just mask symptoms. They could actually correct the underlying gene expression. That's revolutionary, of course. Not everything comes down to DNA. For decades, women have been told their mental health issues are purely hormonal or emotional. But this new research shows it's more complex, a combination of biology, evolution, and environment. Our ancestors evolved in harsh, dangerous environments where being highly attuned to emotional cues increased survival. Today, that same sensitivity meets modern stress. Overwork, inequality, financial pressure, and endless online comparison. The result is a mismatch between ancient biology and modern reality. Epigenetics adds another twist. Scientists have learned that external factors, diet, sleep, pollution, trauma, even chronic stress, can literally rewrite how genes behave. These epigenetic tags can silence or activate depression-linked genes. And astonishingly, some of those changes can be passed down to future generations. It means your grandmother's stress could subtly influence how your own brain responds to hardship today. One woman who experienced this firsthand is Maria, a 34-year-old teacher who spent years believing she was just too sensitive. She blamed herself for crying easily, for feeling exhausted after stressful days, and for needing more rest than others. When she learned about these genetic findings, everything changed. She said, "For the first time, I didn't feel broken. I felt understood. That's the power of knowledge. It transforms shame into self-compassion, and hope is growing on the medical front. Early trials using personalized genetic therapies show promise in adjusting stress response. Gene activity reducing depressive symptoms up to 60% faster than conventional antidepressants. These new treatments may soon be designed around your unique DNA profile, providing targeted care instead of one-size-fits-all medication. But here's the truth. Genes don't act alone. Environment still matters, maybe more than ever. Modern life bombards us with triggers, constant notifications, its unrealistic expectations, lack of community, and burnout culture. Genes load the gun, but environment pulls the trigger, which means we're not helpless. In fact, we have the power to rewrite how our genes behave. Simple lifestyle choices, regular sleep, exercise, balanced nutrition, therapy, and meaningful social connection can retrain gene expression through epigenetic signaling. Studies show meditation and deep breathing can reduce inflammation markers tied to depression-linked genes. Exercise can boost the brain's resilience chemicals. These aren't minor fixes. They're ways of talking back to your biology. So what does all this mean? It means women aren't weaker. They're wired differently, with brains designed for empathy, connection, and survival. Understanding that difference doesn't divide us. It helps us build better, more compassionate treatments in workplaces that recognize mental health as part of human health. If you or someone you know is battling depression, share this story. Because the science of empathy begins with understanding, and the future of mental health lies not in blame, but in biology.